moving on to page 2 of our review. And so the function f of x is a quadratic with the solutions to f of x equals 0 being this. X equals -2 plus or minus 3i. So if you have an imaginary solution, if you have that imaginary component, it means the graph doesn't cross the x-axis at all. When you're solving for a 0 and something's equal to 0, you're looking for x-intercepts. So in this case, that would be the answer. And for notes, you should write no x-intercepts. Make sure you write this stuff down. No, or you could say no real roots, or you could just say imaginary roots. For question number 7, you may find all solutions to the following equation in simplest a plus bi form. A is the real component, bi is the imaginary component. When I look at this problem, the first thing I noticed for distribution, x times x is going to give you x squared. So that means we're going to try to factor this. So I'm going to pause my video. I would like you to distribute and then get one side equal to 0. Oops. So I distributed. I got one side equal to 0, and I ended up with x squared plus 10x plus 28 equals 0. It looks like a very basic and simple trinomial, but if you try to factor this, nothing multiplies to 28 and adds up to 10. There's a couple different options. One is completing the square, but we didn't tackle that this year. So you're really left with just the quadratic formula. So in this case, A is 1, B is 10, C is 28. So I'm going to plug these numbers in. And it's all over 2 times 1, so I'm just going to write 2. Now, just as a refresher, when you're doing quadratic formula, let's start with that. Just put that in your calculator and rewrite the problem. So I'm going to move up here. I get x equals -10 plus or minus the square root of -12 over 2. Now, off to the side, I'm going to simplify my -12. So we have our imaginary component, and then I always like to put my perfect square first. It doesn't really matter. So this becomes 2i, and then you have radical 3. So I'm going to rewrite my blue equation, plus or minus. So instead of radical -12, I'm going to write 2i radical 3. Last step is we're going to simplify. The radical 3 is stuck inside that symbol. You can't do anything with this. I'm going to divide everything here by 2. So I end up with x equals -5 plus or minus I radical 3. Just FYI, that can be written as -5 plus I radical 3 and -5 minus I radical 3. Now for number 8, we have y equals 2x squared minus 13x plus 36. Use factoring to find all values that satisfy the equation f of x equals 15. Basically, you're putting a 15 in here and you're solving. So I have 2x squared minus 13x plus 36 equals 15. There's an exponent, so we have to get one side equal to 0. So I'm going to subtract 15 on both sides. 2x squared minus 13x plus 21. This is a trinomial. if you're going to factor this, you need to do grouping. Now, if it just says find all values, you could use quadratic formula at this point. But since it says factoring, that means we want you to practice. So we're going to find two numbers that multiply to 42 and add to negative 13, which is a negative 6 times negative 7. So I have 2x squared minus 6x minus 7x plus 21 equals 0. Take your GCF out just like we did on the first page of this review. So my GCF is a 2x, so I'm going to take out x minus 3, then I'm going to take out a minus 7, and I have x minus 3. So my factors are 2x minus 7 and x minus 3. So if you set each factor equal to 0, 2x minus 7 equals 0, you get x equals 7 halves, otherwise known as 3.5. And if you set x minus 3 equals 0, you get x equals 3. So you could write that as 7 halves, comma 3 in your brackets. The last problem on this page says evaluate the complex arithmetic problem. Show all steps and express your answer in simplest a plus bi form. So when you're doing arithmetic with imaginary numbers, there's a couple things you need to keep in mind. One, imagine the i's act like a variable when you're working with them. Also, you need to remember your cycle. I to the 0 is 1. I to the 1 is I. I squared is negative 1. And I to the third is negative I. And then the cycle repeats itself. So I'm going to pause this video and do double distribution on this problem. Is this concerning? There we go. Oh boy. So what I did was I did double distribution for each group of polynomials. And you can see I tried to color code it. So now I'm going to go through and simplify i's where I can. That doesn't change. What I'm going to focus on right now is I squared. So this becomes a negative 1. So instead of negative 7 times negative 1, that would become plus 7. And the same thing here. So now what I'm going to do is rearrange this. Actually, I'll just rewrite it out and then rearrange and combine like terms. 2i. Negative 7 times negative 1 becomes positive 7 minus 8 plus 16i minus 3i, and this becomes minus 6. So now I'm going to combine all of my constants, my plain numbers. And I get, I believe, negative 17. And now combine i's 35i plus 2i plus 16i minus 3i. That doesn't seem right. I got 5, so that's 37. 37 plus 16, 53. It's supposed to be minus or plus 50. And that is your simplified answer. Make note, the I portion comes second. Don't write 50i minus 17. Negative 7 plus 50i.